Today's tutorial is about a key step of a so-called Wohl-Ziegler bromination. Wohl-Ziegler bromination is the name for the radicalic allylic bromination. And what is the key step we will have a closer look to? It is the reaction of N-bromosuccinimide with HBr, hydrogen bromide, to give elemental bromine and the succinimide. It is important that in that radical process where HBr, hydrogen bromide, is produced, then the transformation to the elemental bromine is rather proceeding smoothly, slowly, that the concentration of that bromine is rather low. Otherwise, not the radicalic allylic substitution would take place as the main reaction, but the simple addition of elemental bromine to an olefinic double bond. So, how does this transformation work mechanistically? Hydrogen bromide reacts with the starting material, the NBS, of course in a simple acid-base process. It is protonated and not at the nitrogen, because if we protonate here we get a cation which is not mesomerically stabilized, but protonating at the oxygen we now have a mesomerically stabilized system. So there is a cation, and therefore the nitrogen bromine bond is polarized even more to the nitrogen, and a partially positive charge is induced for this bromine. We have the bromide as counter and ion, and this can now attack as a nucleophile, and in this case such a complex with a bromine with two bonds will evolve. The central bromine is negatively charged, and this kind of complex is a so-called 8 complex. In the next step, the nitrogen bromide bond will break, setting free the elemental bromine, which will then be consumed in the radical chain process of the Wohl-Ziegler bromination. And this imidic acid is formed as an intermediate. For the last step, we need to achieve the tautomerization. Since we are under acidic reaction conditions, the tautomerization will be catalyzed by the acid. First, protonation here at the nitrogen, again a mesomerically stabilized cation, and the bromide and ion then will react as a base, deprotonating here, and then we are at the final byproduct, the succinimide, which is easily crystallizing out of the solution since it has a very low solubility. Why is this the case? Well, it is easily forming dimers which are connected by two hydrogen bridging bonds, and one can easily imagine that this rather flat association can build up some kind of staples and easily crystallize. Thanks for listening.